bonjour à tous et à toutes. J'espère que vous m'entendez bien, tout le monde. Aujourd'hui, on essaye une nouvelle technologie. Donc, pour la première fois, on va faire une présentation de façon bimodale. Donc, des gens qui vont écouter la présentation à partir de l'application Zoom et aussi des gens qui vont assister directement à la conférence en salle. Donc, on s'excuse au départ là, pour les personnes qui n'ont pas pu se joindre à nous au pavillon de l'Université Laval à l'ESSAD parce qu'on est limité dans le nombre, compte tenu des problématiques liées à la pandémie, on est limité dans le nombre de personnes à la salle de rencontre. Pourriez-vous me faire un signe si vous m'entendez bien, s'il vous plaît, sur le chat? Oui, parfait. Parce que moi, je ne vous entends pas personne. C'est beau. Parfait. Donc, on va commencer bientôt la conférence. Ça va être M. Manuel Rodriguez, qui est professeur ici à l'École supérieure d'aménagement et de développement, qui va présenter notre conférencier d'aujourd'hui. Quand vous allez être prêts.
OK. Bon, alors bonjour, j'ai enlevé mon masque pour quelques minutes. Alors, ça me fait plaisir d'introduire aujourd'hui notre premier conférencier pour cette année académique, pour ceux qui sont des habitués des conférences de la chaire. On a fait pendant une année une série de conférences en Zoom qui ont très bien marché avec beaucoup de participation grâce aux travaux et aux stratégies de François pour les invitations et la promotion. On entame les conférences de la chaire de cette année, mais ce sont des conférences qui sont en association avec le Centre de recherche en aménagement et développement. Donc, cette année, on aura quelques conférences qui sont en association avec le cadre et d'autres qui seront des conférences uniquement de la chaire. Alors, cette année, nous avons une personne qui est très proche aux travaux de la chaire, un ami, un collègue, le professeur Ralf Ludwig, qui est professeur à l'Université de Ludwig Maximilians München en Allemagne et qui est spécialiste de la géographie physique, de la modélisation environnementale et de la gestion des ressources en eau. Il est venu au Canada plusieurs fois pour travailler avec Watershed Monitoring et avec la chaire en eau potable en collaboration avec la Ville de Québec. Et on continue à faire des projets ensemble. On entame quelques collaborations pour les prochaines années. Et il a accepté de venir en personne pour nous présenter une conférence sur la ressource eau et les changements climatiques avec des exemples très récents. Alors, en plus de chercheurs dans le domaine de l'eau, de l'environnement, des ressources en eau et de la modélisation, Ralf a été doyen de la faculté dans son université pendant plus que 5 ans et en administration pendant plus que 10 ans. Il est en année d'études et de recherche, en année sabbatique et il renforce maintenant ses activités de recherche à partir des prochains mois. Alors, j'ai le plaisir de te passer la parole, Ralf. Nous allons avoir une présentation qui est en anglais de Ralf. Ensuite, nous allons avoir une période de questions qui va être gérée par François. Vous pouvez poser vos questions en français si vous voulez. On va les traduire en anglais. Et ensuite, on traduira la réponse de Ralf en français si vous voulez. So, Ralf, thank you very much for accepting coming to Quebec. The screen is yours for the next 25-30 minutes.
Okay, that's a shame. Okay. Okay, thank you very much, Manuel and François, for the invitation, for the introduction. It's really a big pleasure. I can tell you that after several years of not being able to travel, COVID related, it's my first trip that I can take after almost 2 years. And I cannot think of any better way to start a sabbatical term than to come to Quebec. So thank you for having me. And I will try to stick with the time. It's always an issue for me, but I'm sure that François and Manuel will remind me if I'm about to run too late, but I can always skip some slides. For you to know, I think this session is recorded. You can also have the slides. I will leave it with the chair here, and so in case you're interested, and please just feel free to look at the slides, use them for whatever you want. So in order to get started, I would like to talk a little bit about conditions that we find currently in climate change research more in my country, in my home place in Central Europe, in Bavaria, which is a province of Germany. And I would like to talk on water and time, managing water resources under new climate extremes. So I will start with a short preface, and we'll then have a look at observations. Where do we currently stand? I'm sure that most of you will be familiar with most of it. Where are we heading is the key question, especially when we need to argue about which kind of future we are trying to build. And the good news is that we can still build, right? So it's not that we have to have our heads hanging low, so we need to take the considerations into account. I will then present a little bit from a conjoint project that we've been working on for a long time now with many very, very fine and distinguished colleagues from Quebec on the Climex project. And then at the end, I will close with some challenges for water security and water resources management in Bavaria, which will open new grounds to collaboration. So as a preface, I'm not sure, maybe some of you are familiar with the book that was published last year by Andri Snær Magnason from Iceland. On Time and Water is the name of the book, so not On Water and Time. On Water and Time is the name of the book. What I would like to start with, and you don't have to read through all of this, but it's a very important statement that's in this book, and you don't necessarily have to agree with everything that Magnason says, but that's an enlightening way to start the discussion about climate change, because very many times when I speak on climate change in very different contexts, and of course we always have this magical year 2100, and most people say, oh, come on, that's too far, I don't care, 2100, that's beyond my life expectancy. But when you look at this and this conversation that Magnason has with his daughter, 10-year-old daughter in the kitchen, and they're trying to discuss which time span do you actually have a hold on. And from a great-grandmother to a great-granddaughter, it can be something of 250, 300 years, if you're lucky, of course. And that makes it very clear that this, what is written here in red, is something that we should be reminded on whenever we speak about climate change and the necessities that come along with this responsibility that we have. So that's the time that I will shape. So from what I've been trained by my grandparents to what I will train my grandchildren, that's a long time span. And if I try to put this in condition with, okay, I maybe have to, oh, thank you. Just maybe. I hope you can see it now. If you, to the right, there's a figure that is typically published by the IPCC, thank you, by the IPCC. And you can find that goes a little further than 2100, it goes to 2300. And you see there's a huge gap between the bluish lines and the reddish lines. And the question is, where will we end up? And if we look at the year that is listed here, 2182, that's in a range where we can still have a decision on today, whether that is going to be a world that is 7 degrees warmer or 2.5 degrees warmer. I'm not talking about 1.5 degrees. I think that's necessary to have that discussion, but everybody knows who's following that debate is that we're so far from that goal. It's not out of reach, but it's better to consider the options that we have. And those are probably not the 1.5 degree, okay? So the good news is that we have still lots to say between the lower lines and the upper lines, but not when we get there. We have to take the decision now. That's why it is so extremely urgent. And then most of you are, by the current state of knowledge, it's always good to refer to the IPCC. Obviously, in August, there was the first part of the sixth assessment report published, the physical science basis, and most of you will have seen it. A summary for policymakers is highly recommendable. I'm not going to read everything in detail, but what it says that we already, to date, we know already that climate change is underway and it has an impact on many extremes that are already happening on the planet. And it's no secret to say that if we propagate into the future, then these extremes are most likely to be more dominant and more frequent and more intense and more devastating. So that's what we need to consider. And that's what also relevant for water resources management. All right. So what can we take from observations? And I like these figures. I'm sure you may have seen those. Ed Hawkins is a really famous researcher from the University of Reading in the United Kingdom. And so he was building these time spirals to illustrate how temperature propagates over time. And these are observed data, right? And you will see that 1.5 degree, we have already reached, basically. We're very close on a global scale. And then you see all these figures, the color stripes that are now very popular, very famous for the Fridays for Future movement or the Scientists for Future movement. And they are available for the whole planet. So you see the global scale now. You can also have a look at the Bavarian scale, and you can have a look at the Quebec scale. And you see, and I think that's why it's useful to look at different versions of it, because they can be quite different, right? But the overall impression on a global scale is that we have a very, very distinct signal of warming. And that can shape up in very different intensities when you go to a local or regional scale. So please bear with me on that thought. What I like, this is a new way of presenting also the latest findings in the IPCC report. So what we see here is observations. So it's observed change. And when we look at hot extremes as one possible pathway, then you see that practically all over the planet, there's a clear indication of an increase in hot extremes. Surprisingly, in Eastern North America, it's not so clear. But in all the place where I'm from, it's very, very clear. And it also says that the confidence in the human contribution is high, right? So that is also very important as a message that human contribution is practically triggering this figure. And we can look at the same figure when it goes to heavy precipitation. And then, of course, it's not so clear because heavy precipitation is not a continuous thing. It's a discrete thing, variable. And that will change depending on where you are on the planet. And here also you see in Eastern North America, there is an increase. In Europe, there is an increase, especially in Northern Europe. And there's a human contribution that is already visible. It's not perfectly understood, but it's visible and important to state. Now, 2021 has been a strange year, especially in Europe for many reasons. I'm just highlighting a few of these aspects. So the great wildfires in Greece, you know that there have been many wildfires all around the globe in an extreme intensity, but there's also in Greece again. We've seen a tornado in southern Czech Republic. It's not completely uncommon to have a maybe F1, F2 Fujita scale tornado in Central Europe, but that was an F4 tornado, devastating tornado that you typically only find in Nebraska or somewhere in the Midwest of the United States. Then we see on a large scale, when I take a train and I cross Germany going north, so I come from the very south, but when I go north, I'm passing patches of forest that are completely dead. So they were not able to withstand the droughts in 2015, 2018, 2019, 2020. They were all dry and very warm years. And then the bark beetle came in and did the very rest. So harvesting took place on a scale that typically Canada would do in harvesting. And still, it wasn't fast enough to cure the spread of the bark beetle. And if we look at the remaining glaciers that we have, so it's too bad for the people in the audience that cannot see it. Maybe I can move it. I'm not sure if that works well. Okay. Okay. Now I get back to the laser pointer. Then the glaciers are disappearing, and this is the last, well, we have two left in the Bavarian Alps. Not a tragedy for Bavaria, unless those people who love glaciers like me. It's very sad, but it's not a catastrophe. But it will be a catastrophe in Southern America. It will be an absolute disaster in the Himalayan and the Karakoram and all these countries that depend on the water coming from that region. Right? There will be glaciers for a while, but it's changing. And then most of all cases that were in the news that you've probably also seen, we had an incredible flash flood in Germany, in Western Germany, in Rheinland-Palladium and North Rhine-Westphalia. And a year ago, nobody would have figured that it's possible that 200 people would die in a flash flood in Germany. It happened just like this. So, of course, the question comes up now, is this climate change? And it's always very difficult to attribute one single event to climate change. There's lots of attribution science going on these days, and people do find probabilistic and statistical proof that these events are driven by climate change. But I like to reverse the debate. And my typical response to this is, I may not be able to attribute a single event to climate change, but looking at the high intensities and frequencies of such extremes that we currently find is impossible to explain without climate change. So that is the key element in considerations that I would like to keep you in mind. Now, where we're heading, we see the same climate spiral. And now this is handing over, after we reach the presence, to a climate model. And this climate model just propagates into the year 2100. And now we reach the current time, 2020, now here. And then it goes and it goes and it goes and it goes. So this is, of course, a highly sensitive model. And by the year 2100, we reached 5 degrees on a global scale. That would be a nightmare, unbearable. 5 degrees on average on a global scale means maybe in the tropics, 2 degrees. In the polar regions, it's 12 degrees. Imagine 12 degrees Celsius, we're talking. So where are we heading? Many of you have seen these figures, and of course, our prediction or projection of where we're heading depends on the scenario we choose. And currently, we are on a trajectory that is somewhere maybe around the SSP3 or the SSP5. And what we want is a SSP1 versions of this. And that is a tremendous effort to play, but that's how we want to progress. And I found also a very nice way of trying to illustrate this. The IPCC is now also finding new ways to communicating this science. And they say, well, if we look at a heat extreme that was occurring only once in 50 years, by the time of the end of the 19th century, it is now occurring 39 times out of 50 years. It becomes the new standard. So working with return periods or recurrence periods is a good tool to illustrate and to communicate change in climate. This is, of course, in the case that we go on a bad case scenario. And there's this figure that typically usually takes a whole lecture to explain, but I will just try and make it very short. This is the synthesis report on our expectation from multi-model ensembles. This is what the IPCC concludes. If you compare mid-century, mid-21st century, as to the beginning of the 21st century. And you see that red means increase, blue means decrease, and then there's very many small symbols. And I can tell you that for Europe, there's absolutely no good news there. Nowhere. Everything's going in the wrong direction, except for the risk of a drought in Scandinavia is going to be less. But that's not just such a surprise, right? But everywhere else, more heat, more floods, more flash floods, more heavy rain, more wildfires. That's all that comes with our current understanding of where climate is heading. I would like to spend a few minutes on a project, a very nice project that has been ongoing since 2015, and we have been collaborating with this fine group of collaborators that you see here from Quebec for much longer than that. And the CLIMEX project is our lighthouse project so far, working on climate change and hydrological extreme events, risks and perspectives for water resources management in Bavaria and Quebec. So from the Quebec side, I already saw that there are some people I know very well, and I appreciate their presence from Uranos, from the DEAGE of the Quebec government, from the ETS, from the INRS. And one of the reasons for this meeting today is also to encourage to increase that group of collaborators. The research questions that we had, and you see to the right, you see some pictures that were actually driving this project. So you see, and you know, of course, much better than I, that there were major flood events in Quebec in 1996, 2011, 2017, 2019. And in Bavaria also in 2002, 2005, 2013, 2016. And all of these, they qualify, at least regionally, to a 1 in 100-year flood event. Now you have to ask the question, well, if it's 5 events of the magnitude of 1 in 100 years that happened within 20 years, then it's either something really wrong with our ways of assessing a 100-year flood event, or there's some climate change involved. So that's one of the research questions. Do we see higher intensities and frequencies in extremes? We also wanted to know whether we can distinguish between natural variability and a clear climate change signal. I will not talk about this much today. And then, of course, what other impacts must be expected for Bavaria if we assume a pessimistic scenario. So that's one restriction that you always need to take into consideration whenever I present some results. They come under the assumption of a very bad pathway when it comes to representative concentration of carbon in the atmosphere. So the case studies we've been looking at, to the left, you see it's Eastern North America, and to the right, it's Europe. And you see that we chose the case study of the climate model that we've been using in this climate model experiment, a very unique experiment, centered over Montreal in Eastern North America and centered over Munich in Germany. But then we were, due to the funding of the project coming from the Bavarian government, there was a great interest to look into Bavaria and the river basins that we have in our province to see whether climate change is having an active shaping of intensities and frequencies of floods. So the scope was to assess climate change related flood risk in 98 river basins in Bavaria. It says hydrological Bavaria because that's bigger than the real Bavaria. So we take into account also the inflows from Austria and so forth. And the goal was to improve, on the one side, our process understanding. So what is the nonlinear behavior between extreme precipitation and extreme flood, or extreme snowmelt and extreme flood? Because it's not so easy. It's a very highly nonlinear. And with regards to the methods, I believe I'm going to skip that and make it very, to save some time. I can tell you it was a very, very high performance computing intense project with lots of data that we've been creating. So far, we are in the range of about 2 to 3 petabytes of data that this project has revealed. So it's it's a very big one, but I can answer questions in case there's interest. I'm just going to jump over to show you some results for Europe. To the left now, you will see the monthly change of temperature when we compare the end of the 21st century with the beginning of the 21st century. And you need to take the scale into account. Sorry, the scale starts at 0. So all the colors you see is positive. So, and this is the month December and January and February and March and April and so forth. And you see that there's a strong temperature increase in the course of the century, as we expect. In our model, this is amplified in the summer months. So we see the temperature increase in all months, but especially in summer. If we look to the precipitation side, this is where it really gets serious. You see the bluish colors, they indicate an increase in rainfall, and the brownish reddish colors a decrease in rainfall. And we have two distinct seasons. That over the winter in Central Europe, we expect a much stronger rainfall intensity. And over the summer, we expect a much, much lower intensity or quantity of rainfall. And that is imposing grand challenges to our water resources management in the region. Keep this in mind. So we're having a very strong increase in temperature, and we have a very strong decrease in summerly rainfall. So that indicates drought conditions in the summer for large parts of Europe. I'm starting with the floods, and again, you see this is the area. It represents roughly 100,000 square kilometers. Here to the bottom left, you see Germany, Czech Republic, Austria, Poland. So just to give an indication. And now it's a disturbing graph, so bear with me for a second. These are the 98 river basins that we have been working on. This is the 0 line, and this is the change signal that we see. And we see that for almost all the river basins that we have investigated, we see a decline in the mean annual runoff of roughly 20%. So that water is just no longer available. Not because it's raining less, it's just the seasonal distribution that changes, but we have a much, much higher evapotranspiration due to the increase in temperature. And the only, yes, well, this is a spatial representation of it, and you see the dark red, or the red indicates more than 20% loss in runoff, orange 10 to 20% loss in runoff. And you see that only in the Alps, there's a few river basins that seem to have more runoff in the future. And these are the ones that have a small glacier in its catchment. So as long as there's a glacier that can melt over the summer, it will melt much quicker than in the past. So it produces more runoff. And so the mean flow is increasing. But everywhere else, you're expecting a strong decline in available blue water, let's say, in the rivers and lakes and water bodies, and groundwater also. I'm highlighting this area. This is the Main River. I'm coming back to this in a second because this is the most challenging part that we want to show. So looking at extreme flows, there's different ways of how we can look at extreme flows. I'm moving this again, sorry. in a QQ plot, I pick one station here only. That's one in Austria, near the town of Innsbruck. And we can look at this figure basically in two different ways. Oops. So if we look at intensity, we can say that what is currently a 1 in 100-year flood for this gauging station is 250 cubic meters per second. By the end of the century, this will be 390 cubic meters per second. Or we reverse the interpretation, you say we look at the change in frequency. So what is now a 1 in 100-year flood will be a 1 in 10-year flood in the far future. So this is how you can look at both these levels. In both ways, it's no good news, obviously. And we can also try and present this in a spatial way. Again, the 98 gauges that we have, and you only see blue colors here. Sorry, again. So you only see blue colors. Or almost all blue colors. So that means that the intensity of rainfall is, of a flood is increasing. Or we look at frequency. Sorry, I didn't change it. I realize it's Häufigkeit, it's frequency. So we see that the interpretation means an increase in frequency. What is currently a 1 in 100-year flood will be then, let's say, a 1 in a 50-year flood or 1 in a 20-year flood. And due to the specific setup that we chose, we can also determine regional sources of these floods. So where does the flood actually come from? And we can also look at the prevailing drivers of floods. Is it heavy precipitation? Is it snowmelt? Or is it a combination of both? Do we see more compound events? And those compound events are the ones that are really, really frightening us, to be honest, for the future. Very quickly, I'm looking at droughts, and just a funny anecdote by the side is we recently published this paper. Andrea Böhnisch and Magdalena Mittermeier are two PhD studies in my group, students in my group, and Martin Ludwig works at Uhanas. So, and we were looking into the percentage of normal index. It's the simplest index you can think of. But when you come with a more complex index and you publish, then you typically don't find much attention from the public. This time, is the simplest index you can think of, and it was received by, it was on Bloomberg, it was on The Independent in the UK, it was on the Spiegel in Germany, so amazing. And what you basically see in these, I don't know how to say that in French or English, Tortendiagramm, chart diagram, I don't know. So if you look from the inside to the outside, you see that the brownish it gets, the more deviation we have from the normal in a negative way, and the more bluish it gets in a positive way. So we see that some regions in the area are really turning very dry in the summer, and some are turning really wet in the winter, and that's what is currently striking us. And we can also look at spatial representation here. Sorry. Spatial representation here, and we see that especially for the summer months, the drought risk is increasing dramatically. And the percentage of normal index is a bit tricky. It's very easy because it just shows a deviation in percent of the norm. But you need to know the absolute starting value, because if you say you lose 25% of 1,000 millimeters rainfall, that's a loss of 250 millimeters of rainfall, and that's substantial. In the Iberian Peninsula, if you lose 25% of 40 millimeters of rainfall, it's only 10 millimeters. So not a big deal. So the colors are sometimes a bit changing. But we also see that this, this deviation of normal shows us that the drought risk in some regions like the Iberian Peninsula, but also in the Alps and also in Central Europe, is really increasing over time. So this says the frequency of droughts per 20 years, and it shows you in the far future, every year in the Iberian Peninsula will be a drought year. Every year. Right, and you cannot cope with that. It's impossible to cope with that. All right, I'm coming to the last point, and I'm very close to using up my time, but I want to give you a short example of the challenges for water security and water resources management, specifically in Bavaria. And to remind you, the catchment I will be looking at is the Main River. It's not the main river, it's the Main River. This is here, so it couldn't be more central. It's like in the center of Europe. And it's a tributary to the Rhine. It has a widespread on flow, and high flow conditions. We do experience some problems there, and has a strong topographic gradient. It's a wonderful area, actually. A very diversified land use. We have some urban centers, and if we include Frankfurt, it would be 5 million people almost. So on 25,000 square kilometers, 5 million people is a lot, right? It's more than half the population of Quebec, but I think you have 1.6 million square kilometers here. So it doesn't make a difference. And just to illustrate, it can be quite nice. And that's why we are quite concerned about this site, because one of the very few sites in Europe where you can grow excellent wine and excellent hops at the same time. So that's why we worry about this site. Well, the problem is that this is a map of precipitation of Bavaria, and you see the bluish color indicates an abundance of water, and the reddish colors, brownish colors, there's a lack of water. So we have a difference. So where I live in Munich, we have lots of water. And there will be lots of water in the future because we're very close to the Alps, and they serve as a barrier to air moisture transport. If you go to the north, like Würzburg, they have a serious lack of water, and we need to try and find ways to compensate for that difference. So, okay, so this is the area that interests us the most. There is already water scarcity, and there's already conflicts around water. Climate change, as I tried to explain, causes more intense winter floods and very intense and frequent summer droughts. We have land use change and conflicts. The urbanization is increasing. Irrigation agriculture is even coming now. So we don't have a long tradition in irrigation, but we need irrigation now to grow these specialized cultures there. And we also need to support an energy transition from a fossil and nuclear-driven energy system to a renewable-driven energy system. So we see increased risks for river, reservoir, groundwater quality and quantity. That's very big there. We have to maintain ecosystem services due to the Water Framework Directive, and because we know that biodiversity is important. And the city utility operations, they are really the ones that are in charge of managing all water, energy, waste resources. So they are really very big and important in all small communities and large communities in Bavaria. So they need to get connected to us, and we need to get connected to them. Just to show you some figures of a drought and a flood. The Main River is not very big, but you see that it's navigated by quite large freight ships. So they're almost the size of those that you see on the St. Lawrence Seaway. Not quite, but almost. And but the Main River is really tiny. Right? So the management is really critical. And if you have a loss in water level, the operations stop immediately. And that's very critical. We also, as I showed you, have a devastating state of forests in the region. That also impacts water resources, also the quality part. Lots of erosion taking place now on these sites. Gaining drinking water is in this area really difficult. And that's, I'm going to show on the next slide how difficult it is. And then something you also know from the region here, we sometimes more and more frequent have some severe algal blooms in those artificial lakes. So they become a major concern because all the tourism that built up slowly in the region and has become quite attractive is now in question due to the water quality problems that we're facing. Now, how do we deal with this, particularly with this lake, for instance? I already mentioned briefly that since the 90s, roughly, we transport a substantial amount of water from the water-rich south to the water-poor north of Bavaria. And you need to remember that the distance is only 200 kilometers. It's less than Montreal to Quebec, but we have an incredible strong gradient of water. So water is being pumped across the European watershed divide to the water that goes to the North Sea, then it goes to the Black Sea, to augment the low flow conditions that we have in the Main River. So, and we built a couple of reservoirs. This is the one that has the very critical algae blooms problems. The Brombach Speicher or reservoir is the largest reservoir in Bavaria. It's small compared to Quebec standards, but it's critical for us. There's a third one, and you see the canal. This is where the canal pumps water from the south to the north. And in order to operate this system, you have to have very distinct thresholds. And these thresholds are written down in law. So you cannot take any water if the Danube goes below 147 cubic meters. You have to bring in new water if the Main level is below 22 cubic meters. And sometimes you reach a point where you cannot satisfy both. And that happens in 2015 and 2018, and it's expected to happen way more often in the future. So we need to change something. It's not quite clear how to do it. One example here, the drinking water supply, and this is where, of course, here is the big core competence in this issue. The drinking water supply is also very different from the south where I live. So I'm going to show you this. We have a very little effort to gain super high quality drinking water. We have to do nothing. We just put the pipe in the aquifer, and by gravity, it flows into the city. There's zero treatment, nothing. That's how you tap it when you open the tap. When we move north, and this is the region up here, I just visited very recently with some of my students, we have a huge effort to create very little amounts of water. They have 15 wells. They're all 50 to 100 meters deep. And from the 15 wells combined, they can produce 110 liters per second. That's practically nothing. And then they have arsen in the well, natural arsen in the geology there. So they need to do all kinds of chemical tricks to treat that water. So it doesn't work. That's why the area cannot self-sustain its drinking water demand. And that's why we have 12 long-distance pipeline systems that you can see here in parts, and they all tap water from the south. So from the Danube system and from the Lech water system, there's big wells there, and from there they pump it to the north, and that's where we currently are. We know that climate change will reduce the local supply, and it will increase the local demand, because we have conflicts with regards to drinking water, urbanization, industries, irrigated agriculture, and we don't have a solution yet to this problem. So the question is, how can we manage it? What are the best practice examples that we're currently lacking in our province? And I'm coming to the last slide, maybe instead of a summary. So the rationale for all that, what I was saying is that the region I was showing on the last few slides is at a substantial risk, I have to say, for being pushed beyond its resilience threshold. And we have a problem in Germany sometimes that people believe that since we are the country of engineers and whatever, that we have a huge adaptive capacity. And if a problem comes, we'll solve it by engineering somehow. And we are beginning to realize that this is not true, right? So we are being pushed beyond our resilience threshold, and we need to find a new level of responsiveness. So we need to be prepared. More than just being resilient, we need to be prepared, because the changes are so dynamic. And the barriers that I see, at least, that there's a limited awareness of not about climate change. It's not that we have lots of people that complain or argue that climate change is not happening. They know it's happening, but they don't really see the severity that it might impose on us. And this so-called science, society, policy interface operates below capacity, if you ask me, as far as I can tell. So this is something where we really, really need to work on, and we need innovation. So not only science alone, that's of course great, and that's what I do, but that intermediate, the interface, innovation that connects science with practitioners and policymakers and decision makers, that is really something that's not really working very well, at least from my point of view. So the open questions are for us, in be more precise, do we need new or extended reservoirs? And if so, where are we going to build them? We have our country is very densely populated. I already told you. So it's ridiculous in comparison to Canada. We have 83 million people on 347,000 square kilometers. That's, I don't know, that's like, I think that Nunavik is about 3 times the size of Germany alone, where there's 30,000 people. We need new long distance pipelines. Most likely, yes. Otherwise, we cannot really ensure drinking water supply, which is, of course, the most important thing the government needs to ensure. So the question is, where and when can we transfer water? So do we change it on the demand side? Do we need to manage our land differently? Do we need to find ways of getting rid of irrigation agriculture? And all these questions, right? And finally, as a response, and I will just read this. What we need, from my point of view, is a co-design and a co-production of science-driven technical and cross-sectoral innovations to build new climate-resilient development pathways. And the priorities on our side, at least, is to secure the water, energy, food nexus, because that's really where you need to have a multi-sectoral perspective, and that's also currently not very well developed in many cases. We always have to bear in mind that we are, by law, now driven to reduce our emission and keep our emission targets. That's a challenge also to bring that in at the same time. And we also have to build or maintain, if it exists, ecosystem integrity. And so my personal perspective is always on the research side, of course. I would like to extend the Quebec-Bavaria collaboration that we already have within CLIMEX to try and tackle these problems, ideally, of course, in a strong and tight collaboration with the Université Laval and with watershed monitoring, of course. And please just remember that when I showed at the very beginning, 2100 is practically around the corner, right? Not for me, but for many people I know, they will live in 2100, hopefully, right? And they will have to go through the whole thing that we are currently not able to manage. So that's why we better try to collaborate or collaborate even more to mitigate as much as we can and to adapt to what we cannot avoid anymore. So thank you very much for your interest in listening to this talk, and I'm happy to take questions. I think I breached the time limit, but I hope it was still acceptable. Okay, thank you very much. So I think I hand back to the master of ceremony, Francois. You're muted, Francois. We cannot hear you, Francois, in case you are speaking. Oui. Okay.
Excuse me. A new problem with Zoom and pandemic. Maybe another virus about mute. I have an echo on my side. I have no question on from the chat. Do we have any question in the room?
Merci beaucoup, Ralf. Thanks for your presentation. It was very interesting. And I have something more related with modeling. You talk about a lot about the direction of climate change related to the scenario. So we talk a lot about thresholds, dépassement, threshold values, where the climate could just begin warmer and warmer. And could you model this in your modeling, or is it not this generation of the modeling to be the next?
So if I understand the question well, so you're looking whether we are capable of reaching certain tipping points in
reaching the tipping points, and after what could
well, I mean, the modelization that we did that went to 2100. So we also stopped our modeling there. And what we see is that at some point there are some self-manifesting processes that continue to enforce more and more drought, for instance. So the study that we did it's in a way kind of relaxing, because we see that as much as there's more and more summer drought, there's also more and more winter surplus. So groundwater recharge can start, but what we also see is that the groundwater might be filled, but the surface soil is becoming very dry, and thus it's becoming very hot. So what I've not been able to show is that we are developing heat extremes that go beyond anything that we can currently imagine. So really, really severe summer heat, and that is connected, and it's not a model artifact, but it's something that we can explain also by the setup of the model, that when the land surface dries very rapidly, then of course you have no cooling from evapotranspiration anymore, and then you develop lots of heat. And so that's why we see that sensible heat is going up enormously in the summer months. And that I wouldn't really term this a tipping point, but it's something where we see like a dynamo, right? It's strengthening from one year to the other. It's getting warmer, 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 and this is something we can hardly control. From a larger scale perspective, because what we did, I didn't have time to explain, but what we did, we were downscaling on the regional climate model, so just the European and the Eastern North American tile. And so we were not really in a position to look at the large scale synoptic weather patterns with a driving GCM. So in the driving GCM, there's probably many more knowledgeable persons in the audience, but what we do see, that what is also the expectation in the latest generation of models, is that we see more atmospheric blocking action. So blocking that more prevailing high level, high pressure systems that will increase the risk of heat and dryness, especially in the summer. And that there's a higher frequency of low pressure systems going through in the winter that just keeps continuing to bring more and more rain in the winter. So that is not a specific tipping point, but we also see that the trend is so clear and it doesn't go down again. So it could be something that the model provokes, but it's very much in line with the studies that the IPCC has summarized very recently. So I hope it answers the question.
Yeah. Just curious.
Okay. Thank you. I have a question from chat from Giancarlo Cesarello. Within the socio-ecological policy domain, do you think that we should demand stronger feedback to the policy effectiveness to make government not only responsible for establish a policy, but also to monitor the results? Often policy are perceived as the end of the problem resolution.
That's a very good question. So let's say, it's an uneducated answer from a physicist, right? I believe that the accountability and responsibility must be mandated much clearer on the policymakers. I think that in the European Union, at least, we are going in that direction with a new Green Deal that is actually very strongly binding in this realm, at least in theory. In practice, of course, we also see that policymaking and politicians, they are normally binded by their term, and in most of Europe, this is 4 years, and we still see a major afraidness of taking unpopular decisions. In the longer term, what we need to do, I think, is we need to become better also on the scientific side to better communicate these so-called shared socioeconomic pathways. So the scenarios by which we try and image possible futures, and we need to make politicians to get more involved into shaping up these scenarios, because then we can also make them more accountable for what is being done. And I believe that in theory, we are in a relatively good way. What scares me, though, is that in practice, if you look at the Paris Agreement of 2015, in 3 years from now, there will be the first accounting stock taking place to see where all the countries of the world stand. And right now, there's one country on the planet that is in line with its own Paris targets. And this country is Gambia in Africa, right? All the other countries, and even Sweden, I mean, we know that Swedish are typically always best in class. They're not in compliance with their own set goals. So that's why I believe that we still have that very large gap between theory and practice, and including an environmental, socio-political element in this research realm is needed, because otherwise we cannot build climate resilient transformation pathways. I hope that this was close to what you wanted to hear.
Thanks. I have a comment from Nathalie Godet. It was a great presentation. Thank you. Very clear and also very disturbing. I have also a question from Olivier Pitre. What is the state of law for transfrontier water transfers between countries of the EU? An important transfer in out of Bavaria, for instance.
Very good question. There's very clearly defined rules. So as I mentioned very briefly, but that was a correct number. So there's a law in place that we can only tap from the Danube as long as it's above 147 cubic meters per second. That's an agreement that we have with the first downstream country, which is Austria. So the Austrians could sue us if we would go below that value. I know that in 2015 and in 2018, we were so close to a breakdown of the navigation system and of the canal and all these kind of things that we breached this threshold. And it was, the only thing I know, it was settled somehow. So not in court, but it was settled somehow. I suppose that the German government or the Bavarian government paid a fee to Austria to solve it. Altogether, with all the many transboundary catchments that we have in Europe, this question is a very important one, and we do still struggle with some of very old lawmaking that dates back to the end of the Second World War, for instance, between France and Germany. We still have a management of the Rhine River in place that was built after the Germans lost the war. So all the flood water that is going through Germany, all the useful water is going through France. And so we are quite far, despite all the Water Framework Directive questions and despite our intention to set common thresholds, identify common critical compounds, look together at emerging contaminants. There's in some cases still a not very well developed network of communications, let's say in flood modeling. So the river, La Moselle, before it goes to the Rhine, we have half of it is in France and the other half in Germany. And since 10 years, this is now functional. Before that, the French would not report if there's a flood wave coming. So always hit us by surprise if it happened. So there are negotiations taking place. There are already in some parts clear definitions, even by the cubic meters per second. But the overall transboundary watershed management is still problematic, despite the Water Framework Directive, because the Water Framework Directive is an EU directive that applies to everyone in Europe, but each national state can set its own implementation strategy. And that's why we're not really crossing, making the transboundary management really fluent yet. But it's supposed to happen with the next round of Water Framework Directive goals by 2027. Let's see. Right here.
Là, je ne vois pas dans la salle le manuel. Est-ce qu'il y a des questions? Parce que j'ai une autre question aussi.
J'ai une question.
OK.
Ah,
Oups. Le micro est fermé pour Claudia.
Can you hear me?
Yes.
Oh.
Oui.
Okay, my question is the following, Ralf. You were explaining us about the long-term modeling and forecasting for hydrological variables.
Maybe you turn up and you turn on.
Can you put?
Yeah.
Okay, it's okay. Can you hear me, François? Tu m'entends? Okay. So when you are forecasting for so many years ahead, like 100, something like this, or 80, from 80 to 100 years, how you can take into account the changes in anthropogenic pressures on land use, on policy, and take into account this societal but also economical change that can change the land use, but also can impact the adaptation to climate change.
Yeah, that's a very good question. So repeating it maybe for those who maybe couldn't hear. So the question was, how can we take into consideration not only the climate forcing, but also the socioeconomic boundary conditions that will obviously evolve quite dramatically over the next 80 years. And in large parts, of course, we cannot, right? So we do, but we cannot be certain about how it's done. So what we normally do, and this specific project was kind of an exception because the data amount is so huge that we were only able to use one RCP, so the RCP 8.5. But if we would use more model ensembles with other RCPs, so other climate conditions, then the socioeconomics behind it would also need to change. And so what we normally do in our ensembles, we look at various possible socioeconomic futures. So that can be connected to different pathways of land use change. And more sustainable one might be one that is not using lots of fertilizers and not lots of new intensive agriculture, but builds or rebuilds forest. But these are all storylines. So we can identify storylines together with social scientists and try to invert these storylines into some quantitative boundary condition to our model run. So we say that we assume an urbanization increase of 10%. We have a land use model that does the growing of the urbanization alongside the centers of where they already exist. We change forests, or we change current pasture into forest in locations where there's no other use for intense agriculture. So it's quite sophisticated land use models, but these are always following certain assumptions that we have to predefine in our scenarios. So we do, in ensemble modeling, we do take into consideration different pathways of development. So not only climate, but also the accompanying groundworks, let's say, so the socioeconomic forcing that lies behind. But then we are aware that we have a huge range of uncertainties, and that only by lots of probabilistic analysis we can come up with certain pathways that represent a more sustainable pathway, or one that represents a more economy-driven pathway. That's how we try to approach it.
Okay. Thank you.
So what I maybe should note that we're currently working in the CLIMEX phase 2 of the project. First phase was really driven by flood analysis, and now the second is going into the drought realm. And you see that some of the findings that I had already shown. And there, for instance, the conjoint definition with the stakeholders, with the users, with the, not the politician, but the public administration, they all collaborate to define the scenarios that we want to assume for possible futures in that area. And then we come to
for 10, 20, 30, 40.
Yeah, we go to 20, we go to 2060 with the socioeconomic scenarios, knowing that, of course, as we see through the COVID crisis or to the financial crisis in 2008 and 9, that we cannot really predict such things. And if we would take such things into consideration, then it becomes arbitrary.
Okay.
So we follow certain pathways, futures that can happen, each with an equal likelihood maybe. But then sometimes if we have the chance, we can have a very disruptive scenario saying that for whatever reason, we have another pandemic, which is much worse than COVID-19, COVID-20, I don't know, 21. And that has an even stronger impact on the environment, on the economy. So we can do this, but it's always a bit tricky because the model that we take or that we need to make these type of runs is requires a high performance computing system, and you need to spend lots of money and energy on computing time.
Yeah.
I have a question here from Boubacar Balde from Senegal, very far from here. For a good water resource management policy, do you think that it is necessary a priority to put the focus on the urban planning, which integrates the water cycle, and to insist on the circular use of water?
It's a very good point. Again, another very good remark and question. Yes, I would agree with you instantly. Other groups, so not my group, but other groups, they're working on integrated assessment models, and we try to get there, not on the global scale, but on regional scales. So some would argue it's integrated water resources management put in a model that tries to take these things into consideration. Multiple use of water, as far as I know, is something that is heavily being worked on in large parts of Africa. Personally, I have a number of projects with colleagues in Northern Africa, where multiple management ways exist now to try and reuse grey water and wastewater to some certain extent for various purposes. That proves to be quite efficient, I have to say, from what I know. So I would respond to your question with an absolute yes, especially when it comes to urban planning in water-scarce regions, looking into systems that can at least partially fulfill the requirements of reuse of grey water is essential. We will see that also in Southern Europe, and in the near future, maybe also in the Main basin that I presented. in periods of extended drought, the only water you have available is gray water. Right? So if there's no rain coming in, then sooner or later you have only gray water. And if you don't clear and if you don't work on that water very carefully or reuse it for various purposes, you will only be able to put really bad quality water back into the river. And that's, of course, something we need to avoid under all circumstances.
Okay, thank you. We are at the end of this conference. I will speak in French now for the future conference. OK, donc merci à tout le monde d'avoir assisté nombreux à cette présentation de la Chaire, cette visioconférence. Je vous rappelle que vous allez recevoir bientôt la programmation pour les autres conférences de la saison qui vont être données par des doctorants et des postdoctorants de la chaire de recherche en eau potable, associés aussi avec le CRAD. Donc, vous devrez recevoir ça dans les prochaines semaines. La prochaine conférence va être donnée par Andrés, c'est pas son nom, le nom de famille, je me souviens pas, Andrés Ardila Jiménez. Et puis, elle va avoir lieu le 3 novembre prochain. Donc, je vous convoquerai, puis on va vous attendre nombreux pour cette conférence. Merci beaucoup. Au revoir, à la prochaine.